Welcome. In this lesson, we will discuss dividing polynomials. In particular, we are interested in the method called long division. Think back to your third grade, maybe fourth grade. You maybe once learned how to do long division in this method. If we want to do 277 divided by 12, we would first look at the first two numbers, 27. How many times could 12 go into 27 without going over? Well, 2 times 12 is 24. 3 times 12 is 36. So 36 is going past 27, so we'd fall back on 2. So I'm going to change colors here. We would have 2. So 2 times 12 gives us 24, and we would subtract from here. 27 minus 24 is 3. Bring down the 7. Now we think, how many times can 12 go into 37 without going over? And that would be 3. 3 times 12 is 36. Subtract it, we get left with 1. And back in the day, you might have wrote 23 remainder 1. Now there's a way to figure out a decimal. Maybe you learned that as well. This long division idea is what we're going to use to divide polynomials. Side by side here, you'll see arithmetic long division on this side and polynomial long division over here. Okay, our divisor, instead of being just a number, it's going to be a polynomial, such as x plus 2. Our dividend is going to be a bigger polynomial, usually one that has a higher power. What the idea is to eliminate. So for instance, this 2x squared, it goes away, we subtract here. Okay, essentially we're going to get left with a quotient that looks like a smaller polynomial than what we started with. Okay, and potentially we might have a remainder, and I'll talk about what to do with that remainder. So I'm going to show you 2 examples here, and you can always go back into the video to look at them if you have questions or confusion. So let's start by doing 2d to the second power plus 10d plus 8 divided by 2d plus 2. Here's what this looks like. So our 2d plus 2 is our divisor. It goes on the outside. And our dividend is 2d to the second power plus 10d plus 8. I'm going to try to do my best to color code this. What we're interested in is, we're interested in the front, this term, and this term right now. What could I multiply 2d by to get 2d to the second power? Well, 2d times d. So if I were to take 2d plus 2, and I'm going to multiply that whole thing by d. I should have put that out front. I'll put it here. So think, d times 2d, well that's 2d to the second power, and d times 2 is 2d. So when I do this, I always put parentheses here. We're going to subtract. And this is exactly what we want. We want 2d to the second power minus 2d to the second. That cancels out. Now we've got 10d minus 2d. I'm left with 8d. For our next step in this problem, we're going to bring down the 8. Okay? And now our goal is to eliminate 8d. We think, well, what goes into 2d? What 2d times what will get me 8d? 2d times, well, 2 times 4 would give me 8. I don't need to add any d's because that d will come along with it. So we're going to put a 4 up there. And we need to take that 4 times 2d plus 2. We're multiplying everything in front here. So 4 times 2d, that's our 8d. And 4 times 2 is 8. I'll put parentheses around it. We're going to subtract 8d minus 8d. Well, that goes away. 8 minus 8, well, that goes away. And my answer is d plus 4. So our goal is to subtract and eliminate these terms all along until we get to the end. Sometimes we have a remainder of 0. Sometimes we will have a remainder with an actual number. And I'm going to show you what to do with that in the next example. So now we have 4x to the second plus 3x to the third plus 10 divided by x minus 2. One thing to keep in mind when we divide these, we need to write our dividend in standard form. So I need to rewrite this as 3x to the third plus 4x squared. And we actually also need to include the x. Well, there's 0x here, but in order to do the division with this method, I need to include that it's 0x, and then I can put 10 at the end. So whenever we go to divide by long division, we have to rewrite it in standard form, and we have to include any missing terms along the way. So if I didn't have an x to the second power written in here, I would have a 0x to the second power. I can't skip anything. So let's go to our dividing. So we have, this one's going to be a little bit longer, x minus 2 divided by 3x squared, it's 3x to the third power plus 4x squared plus 0x plus 10. Now our goal is to take the two front terms. Here's 3x to the third and x. What could I multiply x by to get 3x to the third? Well, I know I'd have to multiply it by 3. And then x times what gets me x to the third? Well, x to the second. So now it's like I have to take 3x squared and distribute it to x minus 2 in order to get my next row underneath. So 3x squared times x, there's my 3x to the third I was interested in. And 3x squared times negative 2 would be minus 6x squared. Here is where we have to remember these parentheses and this subtraction so we don't get our symbols mixed up here. So 3x cubed minus 3x cubed, that goes away. That is our whole goal every time, is to eliminate the front runner. Now I've got 4x squared minus a negative 6x squared. Well, minus a negative is like adding, so this becomes 10x to the second power. Now I bring down the 0x. And I have a new goal. My front runner now is 10x to the second. I need to think, well, what could I multiply x by to get 10x to the second? Definitely going to have to be 10. So 10 times x, well, that would just give me 10x. So I'm going to need an extra x here because x times x would give me that x squared. So now I'm going to take 10x and I'm going to multiply it with x minus 2. So 10x times x gives me my 10x squared. And 10x times negative 2 would be minus 20x. Now again, I put parentheses because I'm subtracting the whole quantity. So 10 minus 10, well, that cancels. That gets rid of the front runner. That's our goal. 0 minus a negative is like adding. We're left with a positive 20x. I get to bring down that 10. Now we have a new front runner. Now it's 20x. So what could I multiply x by to get 20x? Well, 20. 20 times x is 20x. So now I've got to multiply 20 times the x minus 2, that whole quantity up front. So 20 times x gives me my 20x, and 20 times negative 2 is negative 40. Put parentheses around it so that we can subtract the whole quantity. So 20 minus 20, that goes away. Great. 10 minus a negative 40 is actually a positive 50. So here is my remainder. So when I rewrite my final answer, here it is. I'll change the colors for you. We get 3x squared plus 10x plus 20. And we get, whenever I get a remainder right here, I'm going to add that remainder over the divisor, x minus 2. That is my final answer. This is a confusing method. If these two examples were not enough, call Mr. Ryan over, get help on explaining what's going on here if this is still confusing to you.